The next entry is on properties of exponents. So you should have this page in your packet. It's double-sided. And what we're going to do is we're going to cut out the margins along the side length, along the bottom, and it's going to fit in your book. So when you're done, you have this page. It'll flip open with some examples. So go ahead and pause the video and get cutting. So as you went through the activities, you found that there are different forms and different properties of exponents. The two forms that we write exponents in are factored forms, where we list out all the factors, and then simplified forms. So you've got a lot of different properties of exponents. For each one, we're going to do an example with numbers, and then with variables, and then a more difficult problem with variables. And then we will state what the power is. I'll do an example, then you'll do an example. And we'll keep going through all the properties. First one is multiplying powers. So this is a power here, right? 5 squared, this whole thing is a power. 5 cubed, this whole thing is a power. In factored form, we write it out as, well, 5 squared is 5 times 5. And 5 cubed is 5 times 5 times 5. Okay? Now, what is another way to write 5 times 5 times 5 times 5 times 5? Well, I have 5 times, so that's 5 to the 5th. And the same is true for x. X cubed is written like that in factored form. Same thing with x to the 7th. 1, 2, 3, 4, 5, 6, and 7. So how many x's am I multiplying all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this would be x to the 10th. So by going from the original form and then expanding it out into factored form, I can go back and reduce it. And by doing this, it helps us figure out a general rule. Well, let's try this one out here. X squared times y to the 4th. That looks like this. X times x, and then y times y times y times y. Right? X squared, y to the 4th. And then I'm multiplying that by x to the 4th times y. Now, I can rearrange these, right? Now it's all multiplying, so it doesn't matter if all these x's are on the left and all the y's are on the right. So really, what I'm doing here is I'm multiplying x 1, 2, 3, 4, 5, 6 times, so x to the 6th, and y 1, 2, 3, 4, 5 times, so it's y to the 5th. So I went from this original form to this simplified form. And now we're going to state our general rule. When you multiply powers, okay, if they have the same base, this is 5s, this is x's, y's, right? They have the same base, we keep that base, and we're going to add the exponents together. Okay, we add the exponents together. And as a general rule, we use variables a to the m times a to the n is equal to a, right? The base stays the same, and it's the sum, right, of the exponents. So I'm adding the exponents together, m plus n. So this one here, 3 squared times 3 to the 3rd. This should be 3 to the 2 plus 3, which is 3 to the 5th. And I want you to pause the video and try this one yourself. So if you tried this one yourself, you should have gotten x to the 5 plus negative 3, which is really 5 minus 3, and that's x squared. Our next general rule is dividing with powers. So again, powers 3 to the 6th, that's a power. 3 to the 3rd, that's a power. And notice that these all have the same base, right? This base is 3. 3, x, x's, y's. Okay? So now let's write this in factored form. And you notice a fraction bar here, a big fraction bar. It's to separate it into the numerator and the denominator. So factored form of 3 to the 6th would be 3 times 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3. So that's the factored form. And yes, it's a lot of work, but when you're trying to figure out a general rule, it's really nice to spread things out, right? And then try and condense it and see if we can make that rule shorter. So, we have all these factors of 3, right? Factors of 3. Now what is 3 divided by 3? It's 1. So really, this 3 and this 3 are going to cancel each other out. This 3 will cancel each other out. This one and this one. So what do I have left? Well, that's 3 to the 3rd. And you can do it here as well. X squared is x times x. X to the 7th is x times x times x times x, and then 3 more times. And again, some of those are going to cancel out, right? An x on the top and an x on the bottom, those cancel. These cancel. So on the top I've got nothing left. I can't just write nothing because it's not 0, it's a 1. And that's over 1, 2, 3, 4, 5, x to the 5th. Same is true if we have a original form, right? A problem that's given with multiple variables. I can write it out in factored form. That's x to the 5th times y squared, and then x squared times y to the 6th. And I can start canceling things out. Those are going to cancel. These are going to cancel. No more x's will cancel, but I've got some y's that are going to cancel. So on top, what I have left is x to the 1, 2, 3, x cubed. And in the denominator, I've got y to the 4th. So based on these 3 examples, can I come up with a general rule? So how did I go from x to the 5th, x squared, to x cubed? Or x to the 2nd, x to the 7th, down to 1 over x to the 5th. And what you should have come up with is that to divide powers with the same base, you keep the base the same, and you're going to subtract the exponents. So what that looks like is a problem such as a to the m over a to the n is equal to a to the m minus n. So we're subtracting those. Example 1, 2 to the 7th over 2 to the 3rd. Well, this would be 2 to the 7 minus 3, which is 2 to the 4th. and I'll let you pause, and you can do the next one here. So what you should have gotten is x to the 5 minus 9 which is then x to the negative 4. Now what you might be asking yourself is, what do you do when you have a negative exponent? That's actually the very next rule. So we're going to scroll down. When you have negative exponents, okay, it indicates reciprocation, right? It just means the reciprocal. So you're flipping them, right? You're going to flip and make the exponent positive. What that means is that if you have, for example, x to the negative 3, you're going to put a little fraction bar because it's over 1, and you are flipping those. Okay, you're bringing the power down, and you're making that a positive 3. So it becomes 1 over x to the positive 3. This one here, you'd flip it up. It would become x to the positive 5. So if I have this one that says x to the negative 4, that's really going to be 1 over x to the positive 4. So it kind of combines some of the properties there. Another way to think of negative exponents, just to make a separate example, say I've got x to the negative 2 and y to the negative 3. Okay, just as a separate example. Kind of think of it like this. You're going to cross the line. Right, crossing the line is in the fraction bar, right? Cross the line and change the sign. So this y to the negative 3, if it crosses the line, so it's up here, and we change the sign, positive 3. X to the negative 2, cross the line, change the sign, so it becomes x to the positive 2. Okay, so they flip-flop, right? Things that were in the numerator come to the denominator, and we change it to a positive exponent.